Hello guys, I welcome you all to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem. It says that the uniform 30 by 40 inch trap door weighs 200 pounds and is propped open by the light strut AB at the angle given. Calculate the compression FB in the strut and the force supported by the hinge D normal to the hinge axis. Assume that the hinges act at the extreme ends of the lower edge. So we are given this uniform trap door which has a dimension of 30 by 40 and it has a weight of 200 pounds and it is kept open by this light strut. So the strut is going to apply the force in this direction, and as a reaction the door is applying the compressive force on this strut in the opposite direction. So we have to find that compression force. So if we apply the strut force on the door, so the same force will be applied by the door on the strut. And further we are required to determine the force supported by hinge D, and that force need to be normal to the hinge axis. So HD we will have three reaction forces. We will have this one, this reaction force and this reaction force, but we are only required to determine the normal forces to the hinge axis. So to solve this problem, first I need to define my coordinate system. So let's say that at point C this is my positive x-axis, and then at point C let's say that from in this direction, let's say this is my positive y direction and this is our positive z direction. Now we are given this angle. This angle is theta equals to tan inverse 4 divided by 3, and tan inverse 4 divided by 3 is 53.13. So let me write that the given angle is 53.13 degrees. Now if I draw a line which is parallel to the y-axis, this dashed line is parallel to the y-axis. So if this angle is 53.13, then this angle is also 53.13. Since this angle and this angles, both of these angles are alternate angles, and we know that this side of the door is 30 inches. This is given. So if this angle is 53.13, then this length along the z-axis is 30 sine of, let me write that from here to here, this is 30 sine of 53.13, and then this length, this is 30 cos of 53.13. Now why we are finding these dimensions? Since we want to find the coordinates of point B and point A, since we want to have the Cartesian vector representation of FB. So let me write that FB vector, which is the force applied by the strut. So FB is acting in this direction. So let's say this is our FB direction, which is acting from A to B. This is FB. So FB Cartesian vector will be equal to FB magnitude times the unit vector, and the unit vector is from A to B, and we can write that FB, and the unit vector from A to B can be written as the position vector from A to B divided by its magnitude. Now to find the position vector from A to B, we need to have the coordinates of point A and B. So point B is at a distance of 30 sine of 53.13 along the z, then 30 cos of 53.13 along the positive y, and then 8 inches, this 8 inches in the negative x. So now let's say that 30 sine of 53.13, so this is approximately 24. So this length is 24. Let me write that this length is 24. This is 30 sine of, this is 24 inches, and 30 cos of 53.13, this gives us 18. So this distance is 18 along the y-axis is 18. Let me write it like this. Now the coordinates of point B are, let me write point B coordinates somewhere here, let's say. So point B is at a distance of 8 inches in the negative x, so I will write -8. Then this distance 18 inches in the positive y, so +18, and 24 inches in the positive z, so I will write +24. These are the coordinates of point B. Now the coordinates of point A are, since point A is on the y-axis, so its x coordinate is 0, its z coordinate is 0, and its y coordinate is 30 inches. So this is 30. So these are the coordinates of point A and B. Now the position vector from A to B will be, we can find the position vector from A to B by subtracting the coordinates of A from B, by subtracting the coordinates of the tail from the head. So now we can write that. So this will be -8 -0. So this is -8 -8i, then 18 -30. So this is 12, and this is -12, right? 18 -30 is -12, and this is in the j, and then 24 -0. So this is +24k. And now to find the magnitude of this, we need to take the squares of each component. So 8 square plus 12 square plus 24 square, and then we need to take the square root. So this is square root 8 square plus 12 square plus 24 square. So this gives us 28. So this magnitude is 28 inches, remember. So from this 28 inches, we can say that the length of the strut when the angle is 53.13 is 28 inches, right? So now FB, we can write that FB is equal to FB magnitudes, and then we need to divide this each component of the position vector by its magnitude. So this will be -8 divided by 28, and let me multiply this FB inside as well. So we will have -8 divided by 28 FB in the I, let me write it like this, and then -12 divided by 28 into FBJ, and then plus 24 divided by 28 FBK. So this is the Cartesian vector representation of FB. So FB has 3 components, right? Now let's remove these coordinates, let's erase these coordinates, and now let's show the components of this force. And at point A, let's say, so FB have one component in the negative x, we will have, this will be FBx, then FB has one component in the negative j, so this is FBy, and it has one component in the positive z, so this is FBz. And at hinge D we will have 3 support reactions. Let me draw those reactions. So we will have dx, then we will have dy and dz. But in the problem statement we are asked to determine the reaction forces at hinge D normal to the hinge axis. So dx is parallel to the hinge axis, so we are not required to find this, right? So we have to find dy and dz, and then we have to find the combined resultant of dy and dz, and that resultant will be normal to the hinge axis. So first of all we have to find FB. So in order to find FB, if I apply the summation of the moment about the x-axis, if we apply the summation of the moment about the x-axis, that must be equals to 0. And as we can see that this dy and this dz, both of these are unknown, but they are intersecting with the x-axis, so they are not going to produce the moment about the x-axis, so they will not come into our equation. Similarly, this Fby is passing through the x-axis, it's not going to produce the moment about the y-axis, it's intersecting with the x-axis. Fbx is parallel to the x-axis, it's not going to produce the moment about the x-axis. So only Fbz is producing the moment about the x-axis. And as we can see that this Fbz is going to produce the moment about the x-axis in this direction. And if we curl our right hand fingers in this direction, so our thumb will point out in the positive x. So this means that the z component of Fb is producing the counterclockwise moment. So I will write plus Fbz, and the perpendicular distance of Fbz from the x-axis is this distance, which is 30. So the moment produced by Fbz is 30 times Fbz. And similarly, in the problem statement it said that the door weighs 200 pounds. So the weight of the door is going to act vertically downward, that is in the negative z direction. Let me show that weight as well. So that weight will be acting at the geometric center of the door, and the weight is going to act vertically downward. So now we want to find the moment about the x-axis, so the weight is going to produce the moment about the x-axis. Let me show the weight in the front view. Let's say if we draw the front view of this door, so we will be able to see the z-axis and the y-axis. This will be our y, this will be our z, and the door is like this, and the weight is going to act at the mid length. This is the weight, and we know that this length which is parallel to the y-axis, this is 18, right? So let me write that this is 18. So now the weight is going to act at the geometric center of this door, and the geometric center of this door will be 20 by 15, right? So this will be the coordinates of this will be from here, this will be 15, and from this corner that will be 20. So the perpendicular distance of the weight from the x-axis is out of the screen, right? So the perpendicular distance of the weight from the x-axis is this distance, and this distance will be half of this 18, since weight is acting at the midpoint. So this extreme corner is at a distance of 18. So if the weight is acting at the mid length of this edge, so then this distance will be the half of this 18. So we can say that the perpendicular distance of the weight from the x-axis is 18, and the weight is going to produce the moment about the x-axis in this direction. And if we curl our right hand fingers in this direction about the x-axis, so the thumb is going to point out in the negative x. So this means that the weight is producing the clockwise moment about the x-axis, and the weight is 200 pounds, and the perpendicular distance of the weight from that x-axis is half of this 18, which is 9. So I have to multiply this with 9. So this is equal to 0. Now we can write that 30 Fbz is equal to 9 into 200, and similarly if we divide both sides of equation by 30, we will be able to find Fbz. And from the Cartesian vector representation of Fb, this is the magnitude of Fbz. So we can write that this is equal to 24 divided by 28 Fb. So now 9, we can write that Fb is equal to 24 divided by 28 Fb is equal to 9 into 200 divided by 30. So this is 60, and if we multiply both sides by 28 divided by 24, so this cancel out. So Fb is equal to 60 multiplied by 28 divided by 24. So this gives us 70 pounds. So the strut is applying a force of 70 pounds, and as a result the door is going to apply the compressive force on the strut in the opposite direction, and that compressive force magnitude is also equals to 70 pounds. Now to find this dy and dz, we need to apply the summation of moment about the y-axis. Let's say if I apply the summation of the moment about the y-axis, this will be equal to 0. So now if we apply the summation of moment about the y-axis, so this strut force is intersecting with the y-axis, so the strut force is not going to produce the moment about the y-axis. So the weight is going to produce the moment about the y-axis, and dz is going to produce the moment about the y-axis, since dy is parallel to the y-axis. So dz is producing the moment about the y-axis in this direction, and if we curl our right hand fingers about the y-axis in this direction, so our thumb will point out in the positive y. So we can say that dz is producing the counterclockwise moment about the y-axis. So I will write plus dz, and the perpendicular distance of dz from the y-axis is this distance, which is 40, 32 plus 8, right? So the moment arm of dz from the y-axis is 40. Similarly, the weight is going to produce the moment about the y-axis in this direction, and if we curl our right hand fingers in this direction, so our thumb will point out in the negative y direction. So we can write that this is minus weight, and the perpendicular distance of the weight from the y-axis will be the half of this length. So that is, this distance is 40, since this weight is acting at the geometric center of this door. So this is 20, right? So we will multiply this with 20. So this is equal to 0, and from this we can say that dz is equal to 20w divided by 40, and we are given the weight, which is 200. So 20 into 200, so this will give us 20 multiplied by 200 divided by 40, this gives us 100. So dz is equal to the support reaction provided by the hinge D in the z direction is equal to 100 pounds. Similarly, if you want to find dy, we can apply the summation of moment about the z-axis. So the summation of the moment about the z-axis, that must be equals to 0. Again, as we can see that the weight is parallel to the z-axis, it's not going to produce the moment about the z-axis. dz is parallel to the z-axis, it's not going to produce the moment about the z-axis. And this fby is passing through the z-axis, it's not going to produce the moment about the z-axis. And this fbz is parallel to the z-axis, so only fbx and dy, they are producing the moment about the z-axis. Now fb axis producing the moment about the z-axis in this direction, like this, and dy is producing the moment about the z-axis in this direction. So if we curl our right hand fingers about the z-axis in this direction, so our thumb will point out in the negative z. So we will write minus dy, and the perpendicular distance of dy from the z-axis is this distance, which is 40. So I will multiply this dy with 40, and this fbx is producing the moment about the z-axis in this direction. And if we curl our right hand fingers in this direction, so the thumb will point out in the positive z. So we can write that plus fbx, and the perpendicular distance of fbx from the z-axis is this distance, which is 30 inches. So I will multiply this with 30, and this is equal to 0. So from this we can write that dy minus 40 dy is equal to minus 30 fbx. Minus will cancel out from both sides, and we can say that dy is equal to 30 divided by 40, 30 divided by 40 fbx. And now we know fbx, this is fbx magnitude. We don't need to write the minus sign, the magnitude is 8 divided by 28 fb. So this is equal to 30 divided by 40 into 8 divided by 28 FB. And now we know FB magnitude is 70 pounds, so we have to write that this FB is 70. So this is 70. Now dy, we can find dy by multiplying all these fractions. So this is 30 multiplied by 8 multiplied by 70 divided by 40 multiplied by 28. So this gives us 15. So dy is equal to 15 pounds. Now the resultant support at D will be equal to D, and this will be the normal resultant, right? Since we have dz, but since we have dx reaction as well, but in the problem statement it is required to find the support at D normal to the hinge axis. So dy and dz are normal. So the normal support resultant will be dy square plus dz square under the square root by applying the Pythagoras theorem. So now dy is 15 square and dz is 100, so 100 square. So this is equal to 101.12 pounds. So this is the normal force which is supported by hinge D, and the compressive force on the strut is equal to 70 pounds. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems.